Hi, everybody, and welcome to today's webinar. We're going to give everybody just another couple of minutes. I see that several people logging in, and then we'll go ahead and get started. All right. Well, thank you, everybody, for joining us today. We really appreciate you being here. Welcome to today's webinar, Rule-Based and Pattern Matching for Entity Recognition in Spark NLP. Today, we're going to be joined by Danilo Bourbano, who is a software and machine learning engineer with Johnson Labs. He holds an MSc in computer science and has 12 years of commercial experience. He's previously developed several software solutions over distributed system environments like microservices and big data pipelines across different industries and countries. We're really excited for him to join us today. And before we get started, just a couple of quick housekeeping items. Please note that your console is fully customizable. You can expand or collapse any of the modules. And Danilo will be answering questions today in the questions portion here of the modules. So please do feel free to drop your questions in there for him. We also have a chat feature where you're welcome to provide comments and engage with the community as well. If you encounter any issues, please feel free to drop us a note in the chat and we'll get right to it. So with that, I'm going to go ahead and turn it over to Danilo.
Hello, everyone, and welcome to Rule-Based and Pattern Matching for Entity Recognition in Spark NLP. My name is Danilo. I am a software and machine learning engineer at Johnson Labs. Okay, the agenda for this webinar. First, we will talk about rule-based and pattern matching. Here we are going to review the definition of these terms and how we apply it on Spark NLP. Then we will take a look at entity ruler. We will talk about this annotator and how to use its features. Then we will talk about the contextual parser, this annotator also, and how to use its features. And at the end, we will see some use cases where we can apply any of these annotators. So let's go to rule-based and pattern matching. These are techniques which are terms that are used interchangeably when talking about procedures to extract information by finding patterns and matching strategies. Let's take a look at a definition of these terms in computer science to have a common understanding of this subject. A rule-based system is used to store and manipulate knowledge, to interpret information in a useful way. Normally, the term rule-based system is applied to systems involving human-crafted or curated rule sets. Pattern matching is a technique where you test an expression to determine if it has certain characteristics. Regular programming languages make use of regular expressions for pattern matching. In programming languages and applications, pattern matching is used in identifying the matching pattern or substituting the matching pattern with another token sequence. In practice, rule-based is used to store knowledge, for example, through dictionaries. And pattern matching is used to identify or replace tokens through specific characteristics, such as regular expressions or other pattern strategies like distance, size, and shape. So, thinking on a high-level use cases, both techniques are used when we want to retrieve meaningful information to be highlighted or replaced. So, for example, when we have dictionaries, we can use rule-based approach. When we have regex rules, we can use pattern matching. When we also have, when you have specific characteristics like distance, size, shapes, we also use pattern matching. So if we have dictionaries and regular expression rules, we can use both techniques, rule-based and pattern matching. As you can see in Spark NLP, we have annotators with these features, entity ruler and contextual parser. So you can use it for your particular use case. Please bear in mind that contextual parser is only available in Spark NLP for healthcare, which is the commercial version of Spark NLP API. Now, let's take a look at one of them in more detail. So, in Spark NLP, we have two annotators that can use one or a mix of both techniques to extract relevant information from text or to recognize entities of interest in a text. Entity ruler, which uses a rule-based technique and can be found in Spark NLP open source, and contextual parser, which uses a pattern matching technique and can be found only in Spark NLP. So let's start with the entity ruler. As the name implies, this annotator allows us to find entities of interest by defining a dictionary, a set of rules, or both. This is an Spark ML estimator, which means we will need to feed it using entity ruler approach to produce an entity ruler model transformer. We design in this way to let users have the option of defining specialized entity ruler models based on their requirements. So, for example, if I have a set of regular expression rules for phones or PO box addresses and another set of rules for emails and web pages, I could create an entity ruler model to retrieve physical locations and another one to retrieve digital locations. So let's see how we can use entity ruler. As you can see, we define it as another annotator in Spark NLP. As we can see here in these code snippets for Scala and for Python. This annotator requires document and token as input columns. Now let's take a look at the available parameters. We have patterns rules, which is a resource in JSON or CSV format to map entities to patterns. We have any enable patterns regex that enables pattern matching using regular expression. Sentence match is a parameter that defines the level to perform the matching. You will see it later with an example. And use storage, whether to use RocksDB storage to serialize patterns. Now let's see in detail how and when we can use each parameter. Okay, how will you use patterns resource? This parameter is mandatory. When we have data that can be represented as a dictionary and we want to have an exact match, we can use this parameter and feed with data in either in JSON, JSON lines, or CSV format, as you can see here. So we define in the patterns field the word that we want to match. Right, as we have here, dictionary of person that we can define here in patterns. As you can see, this JSON file has a field label and another field patterns, which is an array. Okay. So, for example, if we have a database of names, we can define a person as label, and we can do the same with location. So, what are the patterns resource arguments? As we can see, we have three arguments in pattern resource. We have the path, which is a directory where our dictionary resides. Currently, we support directories for local file system and distributed file systems. Read as, that is the strategy to read the file either as a text, which will read the file line by line, or as a Spark, which will read the results as a Spark data frame. And the options here, we define our results format, either in JSON, JSON lines, or CSV. JSON lines format is recommended for large dataset, as well as using reading as a Spark. So if we want to use a dictionary using a CSV file, we want to read it as, and we want to read this as Spark data frame, we will have to define, as we see here in these code snippets. You'll see, send the required arguments, so contextual parser can read as we want. Now, let's take a look at the next parameter, enable patterns rejects. So now, data has information that can be extracted using regular expression. We can define a set of regular expression rules that matches the entities we want to extract. This parameter is set to false by default. So to define the annotator, we set enable pattern rejects to true. And pattern results parameter to the path for our JSON results, which has the set of rules we require, as is shown in these code snippets. So, for example, we define patterns results files regular expression rules to match fonts and PO box labels like this. For each one, we just define the regular expression patterns in the field. So instead of, as in the last example of using words from the dictionary, we just define the regular expressions and setting the regular expression parameter to true. Bear in mind that patterns in JSON and JSON lines are arrays, so we could define more patterns that match other options we require. For example, these font labels rules match only United States fonts. But if we want to match from other countries too, we just need to add another element to the pattern array with the regular expressions that matches the required country. Okay, now let's take a look at sentence match. This is a new Boolean parameter added since Spark NLP 3.4.1 that allows us to set the level where we want to match the patterns we define. By default, it is set to false. So, which means that the match is done at the token level. If we set it as true, then the matches will be done at the sentence level. As we can see, this is particularly useful when we want to match multi-token data, such as word with spaces. As we can see here, we have some text when we want to match multi-tokens, like word with spaces, like let's say Dr. Jon Snow, as we define here. In that way, we will get that output. And we will go to find matches for each sentence that we have. As in this first row example, we see we have two sentences, and then we'll look for matches in the whole sentence. If we don't set sentence match as true, it will not find a match with the spaces because the patterns will be matched for each token. To have a better understanding, let's recap the use of sentence match with an example. So when we define sentence match as true, it will look for a match in the whole sentence for each of the pattern defined, right? So here we will go to the first sentence in London, Jon Snow is a physician, and then to the other one, in Castle Black, Jon Snow is a Lord Commander. And we'll look for matches for the whole sentence for each one of these. And as you can see, we have the output that we desire. If we have defined this as false, it will go to each token. So it will be from in London, John, only John, then the token Snow, and so on. So we will have only output for a single token, right? So As you can see, the annotator is smart enough to filter overlapping multi-tokens. In this example, it outputs Dr. Jon Snow, right? But does not output Jon Snow that is here in the patterns. You can see here, we have Jon Snow and Dr. Jon Snow. That can be overlapping entities. But it'll take the longest one, Dr. Jon Snow, and get rid of the others. So remember, if you want to match multi-token as in Word with spaces, set sentence match as true. Now, the use storage pattern. This is a Boolean parameter that defines the mechanism used when saving a trained model. When it is set to true, it will serialize the dictionary data using RocksDB. Otherwise, it will use common data structures like arrays and maps. RocksDB allows fast writes and readings, so the annotator should have a better performance by setting this parameter as true, which is the default value. But in case you have some serialization issues because of compatibilities between your cloud environment and RocksDB, you can set it to false. And please let us know about it through our official channel so we can know under which specific cloud provider configurations this could have issues. Okay, that is all for entity ruler. Now let's take a look at contextual parser. This annotator allows us to define rules to find entities of interest using regular expressions and context awareness approaches. It does this using regular expressions that allows to match full and partial matching, a dictionary with a normalized option and context through token distances. This annotator is also a Spark NLP estimator, which means we will need to feed it using contextual parser approach and then produce a contextual parser model transformer. As an entity ruler, we define this way to let users have the option of defining specialized contextual parser models based on their requirements. So, for example, we could define a contextual parser to find disease codes of a particular disease, let's say cancer. Or we can also have a contextual parser to find dosages in clinical records. Now let's see how we can use contextual parser. First, let's take a look at all available parameters for working with this regular expression. We have case-sensitive, JSON path, prefix, and suffix match. As you can see, the parameter names are self-explanatory. However, most of the parameters have a specific behavior depending on the configuration defined on JSON file. So let's see in detail how and we can use each parameter along with JSON file configuration. This configuration file is the most important thing to understand. As we can see, the definition of the annotator is straightforward, as we can see in these code snippets. So let's take a look at the JSON configuration file that we define through JSON path parameter. This is the main entry point to make contextual parser produce the expected output we require. It defines the path for our configuration JSON file, which is really important since it specifies the context required to let contextual parser extract the information we are looking for. A complete JSON format that uses all the available configuration will look like this one. As you can see, we have several fields that we can use to define the context that we need. Let's see the purpose of each field in JSON configuration file to know when we can make use of it. Entity. This field is the label assigned to the match, which can be accessed through metadata output. Rule scope. This field defines the scope at which the matching procedure takes place. For now, it supports sentence and document level scope. We will see when to use each one for the next. And for the next field, let's look at an example to better understand this behavior. So we have a regular expression, complete reject, and match scope fields in our configuration file. As you can see in the field rejects, we define the regular expression rule we want to apply. Complete match, we have here complete match rejects file. When it is true, it returns the tokens that fully matches the defined regular expression. When it is false, the output will depend on the value of parameter match scope. And match scope in this field is used when complete match regex is set to false. It can have two values, token or subtoken, which defines the return value of the match. To make it clear how to complete match regex and match scope work, let's take a look at this example here. So as you can see here, we define our regular expression to match only digits, and we have a token, right, that has alphanumeric values. As you can see, when complete match regex is true, there is no output. And we don't need to use match scope because it only ignores this value when complete match regex is set to true. If the token is a numeric one, then we will have an output, which will be, for example, let's say that if the token is only 987, then the output will be 987. So as you can see, if we want to be strict in the match, the way to go is by defining complete regex as true. Whereas if we want more flexibility, we can define it as false and define the match scope based on the output we expected from it, which is the token itself. As you can see here, when we define token, we have the full match, the full token that has this match. And when we define a subtoken, we will get as output only the portion that has the match. That in this case, with regular expression, we will define have as match only the digits, which is the one that we want as output. The other fields are used to configure context awareness on contextual parser. So let's take a look at it. As stated at the beginning, this annotator is context aware by taking into account word distances. When this configuration is defined, this annotator will also consider the distance to find a match. So we have the configuration file. In the configuration file, the fields context length, prefix, and suffix to achieve this behavior. The context length in this field, we define the distance boundaries that the fields prefix and suffix will use to find a match. By distance boundary, we mean the maximum number of characters before or after the target token, where we expect to see a word. Prefix, in this field, we define the words or tokens that must be presented in a context, the portion of the text defined by the context length to the left of the target word. And suffix, in this field, we define the words that must be presented in a context, or the portion text defined by the context length value to the right of the target word. So, for example, using this sentence as input, if we want to retrieve boy and girl as long as it is surrounded by the words bird or faster, we define this way. As you can see, we define this is the JSON configuration file, and this is the annotator that we define. We just set the JSON path, and everything is here. Right? See, in the example sentence, the word boy is the one surrounded by bird and faster within 50 characters as defined in the configuration file, the output will be boy. Note that prefix and suffix fields are arrays, so we can define any set of words we need. The annotator will consider a match for any of the words in the list. Before going to the last field, let's take a look at one parameter. This is an annotator parameter that is useful for working with prefix and suffix fields. Prefix and suffix. This is a Boolean parameter. As we can see here in the image, we define with true or false, right? The default value is false. So taking into account the example sentence and with the configuration in prefix and suffix fields defined right here, as we can see, prefix with blue and suffix with orange, the output will be like this. If we set prefix and suffix match as false, we will have boy and girl. And if we have as true, we will have boy. So as you can see, this parameter defines whether to use a logical AND operator when looking for a match between prefix and suffix. When it is set to false, we have as output girl 2 because it uses a logical OR operator. In this case, a slightly word matches, so girl is included in the output. Okay, the next fields on JSON configuration file are context exception and exception distance. Context exception, this field works along with exception distance. In case there are some words that do not have to be at the left or right side of the target token, we can define those here. And the exception distance is the distance we want to check for the unwanted words. Following the sentence example, if we want the output to be only girl, then we will have to add the exception fields in our configuration file. And the annotator definition is exactly the same. So we add the context exception and exception distance fields to the configuration files. And as we can see here in this example, since add is an exception that is within the distance of void, then void is not added to the output. On the other hand, since here is farther than 25 characters from add, it is not an exception, thus added to the output. Before we continue, let's take a look at a straightforward example to make sure everything is well understood. Let's say that the goal is to find the graded number on each sentence. For that, we will use the regular expression to match all digits. As we can see here, this is the regular expression. We're using double backslash here, otherwise JSON file will be malformed. As we can see, we have sentences in slightly different forms, where we will need to define rules in the JSON configuration file to extract the graded number that is described in natural language. So in the first example, to start 55, which is graded, the graded number, we will need to define graded as suffix. In the next one, we see a different form of the sentences that make us to use lower as prefix. Right? Now, if we have a document made up of two sentences, then we will need to define prefix and suffix to find a graded number on each one. So we define prefix and suffix here to have the output that we desire, the 55 for the first sentence and 90 for the other sentence. Finally, we can have a scenario in which we will need to define a parameter prefix and suffix as true, when we need a logical AND operator to find a match as long as a word is between prefix and suffix, as in this last example that defines whereas as a prefix to show 45, which is the graded number. If we don't set true, we will have two matches here, 35 and 45, for a single sentence, which is not the desired output. Before going on to the next slide, a quick disclaimer that the output will also depend on the value of context length. If we have a small value defined here, let's say 2, the output will be empty string for all of these examples. So remember that we need to define a variable distance to find the match we expect. Okay, now let's take a look at an example with context exception again. The goal is to find the graded number on each sentence. We define the required regex. And as you can see, in this sentence, these sentences are in a tricky form that is hard to find the graded number. So in this case, we are going to ignore a portion of the text and work with the one we can. Thus, we define exceptions. For this example, we define word plus as an exception, right? To work with the portion that we know we can extract information from, which will be the first portion of the text here. And in that way, we will have the desired output, which is 70. A disclaimer here, remember that the output will depend on exception distance value. So bear in mind that a small distance value could find very few exceptions that could lead to undesired output, whereas a long distance could find too many exceptions. So we will have no output at all. So set a distance that best fits your problem. Now let's take a look at dictionary parameter that on contextual parser. This parameter, we define the path to a dictionary file in TSV or CSV format. It is important to stand out that dictionary has prevalence over regular expression. So if we have a value on regular expression field, it will be ignored. So it's better to drop this field from the JSON configuration file when using dictionary. The annotator definition is really simple. We just set as always, but adding this dictionary parameter. Dictionary here is the way to reference fixed vocabulary for the match instead of setting regular expressions in the JSON. In addition to the words we want to match, we can also define a normalized word that could replace the match. This information will be added to the output on metadata as normalized key. As we can see in this example, in the dictionary, we have the first column for normalized values, and the other columns, the words we want to match. So the annotator looks for all possible matches of the words defined on each row, and will output those matches like in this example, which is boy and girl. In dictionary parameter, we can also define orientation. In this example, we are using the one by default, which is an horizontal dictionary. But we can also define it as a vertical dictionary. So we define this, the orientation as vertical. Then we will need to specify it as we can see in this code snippet to have the same behavior that we saw in the former example. With vertical dictionary, we will have only one column where the first row is the normalized word and all other rows are the words we want to match. There have been many requests from our customers to allow matching multi-tokens as word with spaces in a sentence. Now, since Spark NLP Healthcare version 3.4.1, we can use this feature by defining the JSON configuration file as we see here. Right? We define rule scope, document, and match scope as a sub-token. Then, as you can see in this example, we will have as output for these sentences New York and San Francisco, which are multi-token words. So let's see what we mean by rule scope and match scope in the next slide. What we mean by defining rule scope as sentence is to look for a match on each token of a sentence. What we mean by rule scope as document is to look for a match on each sentence of a document. Now, what match scope value, when we define match scope as token, we are saying that when there is a match, we want the whole content as output. And when we define match scope as subtoken, we are saying that when there is a match, we want only the exact matched content as output. Key sensitive parameter. Let's take a look at this parameter that we haven't seen so far. These parameters tell us whether to consider case sensitive with matching values. So if we are looking for matches for cities, let's say New York, commonly cities are in capital letters, but in the text we have New York in lowercase. Then when case sensitive is false, we will have an output, since we are saying to find matches regardless of words with uppercase, lowercase, or capital letters. On the other hand, when it is true, we are saying that we do care about uppercase, lowercase, and capital letters. So it won't find a match unless the text has New York with capital letters. So let's take a look at an example to make sure we understand the use of rule scope and match scope. In the first example, we are saying to return the whole match and to look for a match on each sentence of a document, right? So since there is a match, it returns the whole sentences. Now, when we say to return the matched content, we use subtoken. And we have as an output New York and San Francisco, which is only the matched content, right? In the next two sentences, we use rule scope as sentence. So it iterates over each token of a sentence, right? Each token of a sentence. So in this way, we find matches at a fine-grained level. So we can return either the whole token, as we can see here, or just a sub-portion of the token that has the match. As in this example, in one scenario, we want the whole car identification number to return. And in the other one, we only want the digits of that identification number. Okay, let's finish the presentation with some use cases of these annotators. As we have seen so far, we can use these annotators basically in anything that has standard entities formats that can be extracted through regular expression or context patterns. For example, to identify documents, you can use it for data obfuscation, like replacing names with fake names, data masking, when we want to replace some dates, for example, the whole format just to a label, let's say date. We can also use this to secure software and security software. We want to have data protection by adding multiple layers of defense through data anonymization to protect sensitive information. So in the worst case scenario that there is a database leak, the more sensitive data is still protected. You can also use it in automated tools to automate annotation workflows. For example, to have a starting point to annotate data in a text. And then you can also want to gather labeled data for training machine learning algorithms, for example, to create datasets, starting datasets for training name entity recognition models. In case you need to extract information that cannot be extracted to regular expressions or content patterns, I invite you to test the identification annotator from Spark NLP Healthcare, which is a deep learning based one. I hope you enjoyed this presentation. You can always have other references for these annotators in Spark NLP workshops, freely available on our GitHub repository. And keep checking our articles posted on Medium for future articles about these two annotators. Have a nice day, and thank you for joining this webinar.
Thank you so much. We hope you enjoyed this great webinar today, and be sure to keep an eye out. You will be receiving an email in the next day or so that'll have a link to this online. You'll be able to watch it on demand at your convenience. Thank you again for joining us. We hope you found great value in today's webinar, and keep an eye out for the next webinar we have coming up next month.